Welcome to Unit 16, Ant Escape Level 1. This is the second Ant Escape program. It's a build on the first one, which was Level 0. In this one, we're going to get into some more difficult concepts, and we'll also have ants in the game, which now will alleviate any sort of stress you had in your life of wondering why there weren't ants in a game called Ant Escape. Okay, so, and that's my fault. I should have known better, but you know how things are. So let's go ahead and look at the program, and then we'll check out some of these learning objectives. Okay, this is the completed program for Ant Escape Level 1. And let's go ahead and run through it here. I might have to stop and put some cheating information in here to be able to complete the game. So our runner will just run through the maze, and you'll notice we added some features. I got a spinning coin here, I have an ant that roams around, and one thing you'll notice in the game is I didn't program the ants to actually stop the player. So for now, we're just going to build it out where there's no interaction between the player and the ants. The good news is you already know how to do these things, okay? I've already shown you how to be able to do collisions, so you can use your items that you learn from other lessons to be able to detect those collisions and then end the game based upon what you've seen in other lessons. But the main thing is I want you to see that we added some ants. We're using the glide tool to get those around. And we got some different ants. You can see we have coins. You can put as many coins wherever you want to go. You can actually attach variables to the coins on how many you collect and do other things. These pickup items, you can actually program them to do power-ups for the player or whatever it is that you want. Okay, here's the main part of the stage I want you to see. I have these new type of ants that you haven't seen. Well, I guess it's all kind of new, but these ants, whenever you hit a invisible trigger, which is laid across here, you can't see it, it'll force this ant to come flying across the screen, and then I have it go very slowly back to its starting position. And I just wanted you to see that. I'll show you how it works in another part of the lesson. Okay, and you can notice I have 3 or 4 of them, and anytime your player is on that invisible trigger, it's going to cause that ant to go forward. So if I come forward and it moves up. Okay, then I add some other items on here, such as these moving kind of walls that kind of crush the player if you were to hit them. Okay, so you'll need to detect if the player is touching one of these objects called the crusher object, okay, and touching the brown color. Now you notice the brown color for the walls of the maze are the same exact color as the crusher sprites as they move back and forth. Okay, and then you escape, and then there's the message that you have escaped. Okay, so that's the game. Nothing super fancy, but there's some pretty cool things taking place here that's going to help you evolve your skills. Let's move back to the presentation here. So these are the main learning objectives you'll get from this lesson, that you're going to use a trigger to create certain actions and reactions in the game. You're going to program some lower level artificial intelligence to roam the maze, and you're going to learn how to use the glide movement to strategically and overcome its shortcomings. So I missaid that. So what you're going to do with the glide tool is you'll use that with the ants on how to move around on the screen. This isn't a perfect tool. I've tried to avoid using it as much as possible. It's very good, but it also, like I said, it has some shortcomings. Next, you want to create some event-driven programming triggers to initiate a series of events in the game. Okay, so one of the things we'll see here in this lesson is something called event-driven programming. This is the concept of actions that cause a series of reactive events to take place. For example, action, reaction. The one that you saw on the screen was the ant that had the invisible trigger that was waiting for our player to hit it. And when it did that, or when the player hit the trigger, it would cause that to make the ant move across the screen. Okay? And this brings up a point right here called an event-driven programming requires a repetitive loop in order to listen for the events. So that ant that had the trigger associated with it, it was listening for an event to take place. Okay, now you're probably thinking the computer really doesn't listen. And that's true. That's just a term that they've kind of developed that has taken hold of the industry. So just know that listening means a piece of code is waiting for something to take place. Now, the exact definition is listening for event refers to the computer waiting for a specific event to take place. And event listening and loops in our programs are going to use the forever, repeat, wait until, and repeat until. And we'll probably use all those in different capacities. Sometimes you could probably mix and match. It doesn't really matter which one you use. Other times there'll be a strategic difference that you need to focus on one and use that one because it has some specifics that cause it to work better than others. The event handlers are the functions that perform the reaction based upon the listening loop, detecting an input from the user or sensor. So over here, the event handler is going to be that we're going to repeat this until it's touching the mouse pointer, and then we're going to move the 10 steps. Okay, so it's performing the reaction of moving the 10 steps until it's touching the mouse pointer. Okay, and you can see right there the input, the user or sensor is waiting for the mouse pointer, which will be from the user. And triggers are used to start up an event, which you saw earlier with the mouse. Okay, so gliding is, you probably used it already. I know we used it in some of our programs. It makes the movement of sprites really easy to go across the screen. One of the downsides is that whenever you start the movement of the sprite with a glide tool, it has to complete that movement, and it can't stop until once it's started, unless you put some sort of function that will program that sprite to stop all of its activity based upon some sort of event or message getting sent to it. Okay. Bad side, glide tool can lock up a function with its movement. So if you look at this tool right here, if our wall is needing to go away and it's in the middle of a glide right here, it's going to keep going until it completes that action, no matter whether we want it to or not. There's some ways to get around it. For example, we could hide the sprite while it's in the middle of a glide, especially these long glides. This one's 2 seconds. You can see it right there. The other one's 1 second or less. Your game could look kind of sloppy if you're letting glides finish out for a second and it's not supposed to be. Users could notice that, especially longer glides. You really want to make sure the sprite's hidden if that glide is long and it needs to go away. Okay, so the speed of the glide can be manipulated by lowering or increasing the time it takes to travel. So just think of speed. If you increase the time for the glide, it's going to go slower. If you decrease, it's going to go much faster. Okay, all things staying equal if you were going to the same XY coordinates from the same location. And you'll notice here on our crushers and our ants, we'll be using the glide extensively. Now, one thing to note with the glide is you got to make sure you have a starting XY location. Okay, the glide just moves the sprite from wherever it is to the XY coordinates you put inside of its data input sections. So if you don't set it to an initial XY coordinate, it's going to just glide from wherever it is to wherever it is that you're telling it to go. And some people forget about that and they don't set the XY coordinates, and the sprite has glided to its location. They stop the program and they start it again, and it's still at that current location, so they don't see any movement because it's already there. Okay, so just keep that in mind when you're going through these programs. Ant trap trigger 1. So this is how the trap works. It's an invisible line. Let me switch over to Scratch here. Okay, you can see that here's my trap. Okay, this is a pretty simple piece of code. Let you pause the video and you can check it out. And what I've done is I've set the ghost to 99 so you can't see it. And then we've just set it to certain XY coordinates. Then we just keep telling it to repeat until it's not level tracker equal 5. So this piece of code won't run until it's level 5. Okay, and once it receives that level 5 message from the broadcast, which this is the same as level 0, it's going to keep repeating this until the level changes from 5. Okay, so as long as the level is 5, this piece of code is just going to keep running no matter what. But once it's not running anymore, then it's going to turn off, and there you have it. Okay, so while it's running, if it touches the runner, we're going to broadcast this message called Ant5 Trap Level 5. Okay, the name's not important. It's kind of specific. I bet you can figure out which ant receives this message. It'll be Ant5. And when Ant5 receives this message, which is Ant5 Trap Level 5, it's going to tell the ant to glide to its XY coordinates, and then we have a glide back. If you remember in the program, when it glided really fast, that was because of this low speed right here. Or excuse me, high speed, because I lowered the time. And And then right here, glide slow, because I increased the time, which causes it to glide slowly back to its starting location. So that's the essence of the trap. I picked a neutral color for the bar because I'm using colors to detect collisions with the player, just like we had done in level 0. It's not the ideal way to program a game. However, for our learning purposes, it's a pretty effective way. So, you know, we're just going to go ahead and stick with that. And right down here, I put in a little note that this trap right here is completely visible. As you saw in the game, it's completely invisible and you won't be able to see it. Okay, the second half of the notes for the AMP trigger is something I had already talked about, but I didn't talk about this block, broadcast and wait. Okay, so what's happening with this tool right here on the ant, and this is ant 9, it was the same for any of the ants that use the trap, is that whenever we broadcast this message, it's a broadcast and wait message. And so when it sends the message out, this whole script will stop until this piece of code right here completes its actions. Okay, so it won't let this piece of code move forward until this is done. And there's nothing you have to do to send a message back. If this was more advanced language, you would, but in our case, Scratch is taking care of that. So it sends that message, and this will just keep waiting until this is done. Now you have to watch out. If this takes a long time, this will continuously sit there and wait until it's done. And let's see, pick up items. You saw the coins. Just made a real simple graphic here for making the coins spin around the screen. Let's see, right here. So we're just going to keep repeating the action until the level tracker is not equal to 2. Kind of same concept with before. So the coin will just stay on the screen and keep spinning. And it's going to wait till it's touching the sensor. Once that level is no longer active, that means the player's gone to the next level. We will double check to make sure it's not touching or it's touching the sensor. If it is, we'll broadcast the coin effect message, which will play the sound effects on another location, and then we change the variable by 1. Okay, pretty simple. You can pause the video and check out these notes right here. And that is Anescape level 1 all wrapped up. There's a lot of details. This is pretty long and tedious. I would encourage you, when you go through these things, figure out where you can copy a lot of the code back and forth between the sprites to save yourself some time, especially when you get into the coins. A lot of people that don't know how to copy the scripts, I don't show them how to do it because I figured that's it'd be good for you to figure out how to do on your own. So I'm going to let you figure that out on your own. It's how to copy the scripts from coin to coin to coin to coin, and the crushers and the ants, and see if you can save yourself some time. All right, good luck, and we'll see you in the next video.